Hi, I'm Paul Kyogan from GKTuition, and in this video I want to talk to you about trigonometry. Now the question that I've chosen to go through here is 2017 Paper 2 Question 6 Part A. In this question we're told that the radius of the Earth is 6,371 kilometers and that Jack is standing on the cliffs of Moher that are 214 meters high and that he's looking at a point on the horizon H. Now you should recognize that his line of sight must be a tangent to the circle. So I know that this must be a right angle triangle. First of all, we're dealing with two different units. So since this is given as 6,371 kilometers, the first thing you should do is convert your 214 meters into kilometers. There's 1,000 meters in a kilometer, which means to convert this to kilometers, I divide by 1,000, so that's equivalent to 0.214 kilometers. So in other words, I know the distance from A to J is going to be 6,371.214 kilometers. Now, this question is asking me to find the distance JH. So if we look at our diagram now, I have two sides in a right angle triangle, so I just use Pythagoras theorem to find my distance JH. Pythagoras theorem is that a squared plus b squared is equal to c squared. And in this case, my c is always going to be my hypotenuse. So if I sub in here, I can say that 6,371 to be squared plus JH to be squared must be equal to my hypotenuse to be squared, which is 6,371.214 to be squared. So if I just want to isolate my JH, I can just say that JH to be squared is equal to 6,371.214 to be squared minus 6,371 to be squared. So to get JH on its own, it's just the square root of all of this. So I just plug all of this into my calculator, and the question asked me to get it to the nearest kilometer. When you plug all of this into your calculator, you'll work out that JH is 52.2 kilometers. So clearly if it's to 0.2, that means I'm going to round down. So JH to the nearest kilometer is 52 kilometers. Okay, part B tells me that the cliffs of Moher are at 53 degrees latitude north of the equator. And they're asking me to find the length of the circle S1. Find the length of the circle that's a latitude 53 degrees north. To be honest, in this question, you don't need to get too bogged down in the 3D shape. We can just boil it down to a relatively straightforward triangle, a relatively straightforward 2D shape. I've been asked to find the length of the circle. Another way of saying that is find the circumference of a circle. And if you look at your maths tables, to find the circumference of a circle, it's L is equal to 2 pi r. So in other words, I need to find the radius of the circle S1, and that will allow me to work out the circumference. So I need to find the distance from S1 to C. Okay, and that'll allow me to find my circumference. So rather than finding the distance from S1 to C, what I'm going to do is find the distance from S2 to here. I want to find the distance from S2 to here, which is clearly the same thing as the distance from S1 to C. Remember, I know the radius of the circle in this case is 6,371. And I know, right, so I'm dealing with a right angle triangle and I'm looking for the adjacent. Okay, so let's call this the distance W. Okay, I'm looking for the adjacent. W represents the distance from S2 to my little x here, or in other words, the distance from S1 to C. So I just have a right angle triangle. And I know the 53 degree angle, I'm looking for the adjacent, and I know the hypotenuse. If I'm dealing with the adjacent and the hypotenuse, that means I'm dealing with cos. So I can say that the cos of 53 is equal to the adjacent, which is W, over the hypotenuse, which is 6,371. So in order to get W on its own, I'm going to multiply both sides by 6,371. So it becomes 6,371 times the cos of 53 is equal to W. Now clearly this is in degrees, so make sure your calculator is in degrees. And if you plug all of this into your calculator, you get 3834.1625. Sorry, 1635. So I know the radius of the radius of my circle S1 is 3834.1635. Once I know the radius, it's very straightforward to work out the distance, or in other words, the circumference. Sorry, the length or the circumference. So I know the length of my circle S1 is 2 multiplied by pi multiplied by the radius, which is 2 multiplied by pi multiplied by 3834.1635. If I plug all of that into my calculator, my answer works out as 24090.76. And it asked me to get it to the nearest kilometer. So the radius of the circumference of my circle S1 to the nearest kilometer is 24,091 kilometers. And that's my final answer for part B. So I want you to just notice that question, when you open that page in your Leaving Cert, that's a very intimidating looking question. The diagram looks very complicated. And yet, to me, that was actually the easiest short question on that paper. The maths to it was actually very straightforward. I think just make sure you don't get intimidated by complicated diagrams, because often when the diagram's very complicated, the maths itself isn't actually too bad. All of that is junior cert trigonometry. That maths, in junior cert you could have to do that maths. The only thing that makes it harder here is that the diagram is that little bit more intimidating. So I hope this video made sense. If there's anything you're unsure of, as always, just let me know in class or send me an email and I'll try and clarify it for you.